On the AP exam, there will be 4 free response questions. This video is modeled after FRQ number 1. It's about composition, zeros, limits, and inverses. Let's pretend it's from the 2007 exam. If you appreciate this content, please give it a like. The figure shows the graph of the decreasing function f on its domain of all real numbers x. The points -1, 10 and 3, 5 are on the graph of f. The function g is given by g of x is equal to this expression. A part 1. The function h is defined by h of x equals g of f of x. Find the value of h at 3 as a decimal approximation, or indicate that it is not defined. This problem is calculator active, so let's go ahead and type function g in as y1. If we need to evaluate g later, we can just evaluate y1. H of x is equal to g at f of x, so h at 3 is equal to g at f at 3. F at 3 is 5, so this is equal to g at 5. We just typed function g in as y1, so we just need to evaluate y1 at 5. You can pull up y1 by hitting alpha, trace, enter. And you can evaluate y1 at 5 by putting 5 in parentheses like this and hitting enter. So that's the answer, -281.02. A part 2. Find all real zeros of f, or indicate that there are no real zeros. The zeros of f are the x-coordinates of the x-intercepts of f. But there is a horizontal asymptote at y equals 2 that f is approaching as x increases without bound. So there are no x-intercepts. So no real zeros exist. B part 1. Find all values of x as decimal approximations for which g of x is equal to 10, or indicate that there are no such values. We can find where g of x equals 10 by finding the intersection of the graph of g with the line y equals 10. Alright, y equals 10 is right at the top of the screen. I'm going to adjust the window a little bit. Let's make y max a little higher. Let's make it 15. So there will be 2 intersection points. We can find them by hitting second trace and choose option 5 for intersect. Move the pointer close to the first intersection and hit enter 3 times. Enter, enter, enter. So there's the first value. X is equal to 0.8561. By the way, the College Board will accept 3 decimal places. However, some students lose a point because they round wrong. So I recommend always using 4 decimal places and never trying to round. There's our first solution. Let's go back for the other one. Again, hit second trace and choose option 5. We need to slide over to the other intersection point. I'm going to hit the down arrow key to jump onto the red line. Just makes it a little bit easier to slide over to that other intersection point. So, get close to the intersection point and hit enter 3 times. Enter, enter, enter. Kabam! 3.8770. That's it for B part 1. B part 2. Determine the end behavior of g as x increases without bound. Express your answer using the mathematical notation of a limit. So let's see, as x increases without bound, we are talking about the limit as x approaches positive infinity of g of x. First, let me show you how to do this without using a calculator. When a function has even degree, like x squared, x to the fourth power, or x to the sixth power, the end behavior is the same on both sides, like positive infinity on the left and positive infinity on the right. If the leading coefficient is negative, then both ends are pointing down. So the limit would equal negative infinity on the left and the right. When a polynomial has odd degree, the end behavior is positive infinity on one side and negative infinity on the other side. And specifically, if the leading coefficient is positive, it's like this. The end behavior is positive infinity on the right and negative infinity on the left. If the leading coefficient is negative, the end behavior is reversed. The end behavior on the right-hand side is negative infinity, and the end behavior on the left side is positive infinity. The function g is given by this polynomial. We see that the degree is even, and there is a negative leading coefficient. That means g is approaching negative infinity on the left and the right. The limit as x approaches positive infinity is the end behavior on the right, which equals negative infinity. If you forgot this information on the exam, you could confirm by checking the graph on your graphing calculator, but you might need to zoom out to make sure you have the right view. I've hit the window button, and I'm adjusting the y min to be negative 100 and the y max to be positive 100. Sure enough, the end behavior on the left and the right is negative infinity. See Part 1. Determine if an inverse function of f can be constructed for all values in the domain of f. In Algebra 1, you might have learned that a function has an inverse if it passes the horizontal line test. Notice how any horizontal line you draw will only hit one point at a time. So function f does have an inverse. The horizontal line test is good enough for Part 1 and allows us to say, yes, an inverse function of f can be constructed. However, be careful, it's not good enough for Part 2, which says give a reason for your answer based on the definition of a function and the graph of y equals f of x. For this part, it is not good enough to say that f passes the horizontal line test, nor is it good enough to say that f is a one-to-one function. So what do you say? You have to say an inverse function of f can be constructed because each output value of f of x is mapped from a unique input value. AP graders are telling me that they are going to be very picky about this answer. You pretty much have to provide this response word for word. So memorize it and practice it. Let me just emphasize that you need to start by mentioning the output value and then finish by mentioning the input value. Also, to earn the point, you must say the output value of f of x. If you leave this part out, you will not get the point. Also, be sure to use the word unique. So one more time for reinforcement. An inverse function of f can be constructed because each output value of f of x is mapped from a unique input value. Before I end this video, I want to show you what the answer would look like if f of x fails the horizontal line test. You're going to use the same wording as before, but you're going to say not in the middle of it. By the way, this time they worded the question by saying determine if f is invertible. That means the same thing as does f have an inverse? So it failed the horizontal line test, so we say no, f of x is not invertible. Or no, f of x does not have an inverse, because each output value of f of x is not mapped from a unique input value. Now be careful, there is something different that you have to do when the answer is no. If you stop here, you will not earn the point. You have to provide an example to illustrate what you're talking about. For example, f at -2 is equal to 2, and f at 4 is equal to 2. Now you've earned the point. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.